Students, today we're going to see a new experiment wherein we're going to check how to obtain a solution for a difference equation. So before we understand this particular code, let me explain a problem associated with this particular code. So let us consider this particular problem. Find the 25th term of a Fibonacci sequence. So you know the general Fibonacci sequence. Now first two values are 0 and 1. 0 and 1. Now this is at n is equal to -1 and this is n is equal to -2. Here is n is equal to 0. So if you add preceding values, you will get the present value. Similarly, if you add preceding values, two values, then you will get new value. Add last two values, you will get new value. You can easily tell Fibonacci series, first 10 Fibonacci numbers. Suppose if I ask what is the 100th Fibonacci number, so it will take time. So what we can do here is we can express this Fibonacci series in the form of a difference equation, and if we can find out a solution for it, and if you hold that particular solution, it's like a one-step solution. Whatever be the value of n, whatever be the term, that is 100th value or 200th value, you can easily get it. No need to calculate it from the beginning, or no need to go through a lookup table. So that is what is the importance of solving a difference equation. So we'll take one such example wherein we're going to solve for a Fibonacci sequence. And Fibonacci series can be mathematically expressed in the form of a difference equation as y of n is equal to y of n minus 1 plus y of n minus 2, because we'll add previous two values in order to get present value, where y of n is present value, n minus 1 is last value, and last but one value. So if you add last value and last but value, one value, you will get present value. That's what Fibonacci sequence tells us. But there are some initial conditions. They are at n is equal to -1. We need to assume it is 1, its magnitude is 1, this value, and n is equal to -2, its value is 0. Now we'll see how to solve this. So here it can be solved like this. I'll take the given expression, Fibonacci sequence, y of n is equal to y of n minus 1 plus y of n minus 2. So I'll solve for this. Okay, this can be expressed like this. So here I'll consider y of n as 1, n minus 1 as r power minus 1, n minus 2 as r power minus 2. Multiply by the highest power, it is -2, right? So multiply by r square. R square into 1 is r square into r power minus 1 r power minus 2 into r power plus 2, it is 1, that is equal to 0. If you solve for this particular equation, you'll get the values of r1 and r2. Using that, I can express y of n as k1 into 1.618 power n plus k2 into 0.618 power n. Now I need to solve for k1 and k2. So we know that there are two initial conditions here. That is, when y of minus 1, its value is 1, and at y of minus 2, its value is 0. I'll make use of these two initial conditions, and I'll go to express this equation with the help of this. Okay, here what I'll do is I'll substitute n is equal to -1 in this particular equation, so that you will get y of -1, and the value of y of -1 is 1. That is equal to k1 into this constant power -1 plus this constant into power -1. I call this as equation number 1. Similarly, I'll substitute n is equal to -2, so that you will get y of -2 in the value at y of -2 is 0. That is equal to k1 times 1.618. The value of n is -2 plus k2 times minus 0.618. The value of n is -2. I'll call this as equation number 2. What I'll do is I'll solve for equation 1 and 2 now. So once you solve for equation 1 and equation number 2, you will get the values of k1 and k2. Now I'm going to back substitute that in this particular equation, so that I'll get this particular expression, which is a one-stop solution to find Fibonacci number at any given term. Say for example, let us consider the at n is equal to 0. So what you should get as at n is equal to 0, it should be 1, right? So as per this particular sequence, at n is equal to 0, it is 1. So we'll check for that. Now substitute n is equal to 0, you'll get y of 0, that is equal to 1.171 into 1.618 power n. What's the value of n? n0. Something power 0 is 1. So you'll get 1.171 plus minus 171 into something power 0, it's 1. Now this is minus, this is plus. So as a result, 1.171 minus 0.171. What is the result? Y of 0 is equal to 1. Is it that we needed? Yes, of course. Similarly, you substitute for various other values of n, you will get various values of y of n, which will be similar to this. You can consider any value of n, say for example 100, substitute that here, you will get 100th Fibonacci number. So this is what is the advantage for obtaining or for solving a difference equation. Now we'll check the MATLAB code for the same. CLC clears command window, clear all, clear workspace variable, close all, closes any additional window that has been opened. A, enter A coefficients. There are some coefficients associated with difference equation. So I'm going to enter that. I'll ask user to enter. Similarly, we are asking user to enter B coefficient. And if there are any initial conditions in this present equation, we have initial conditions. So that we're going to enter at line number 7. And if there are any initial condition with respect to variable x, we're going to enter that. And n, how many points we need. So in this example, I took first five Fibonacci numbers, right? 1, 2, 3, 4, 5. So n could be anything. It could be 5. If n is 5, you'll get back this as your answer. So we'll check for n is equal to 5 only, so that we'll get this value. That is 1, 2, 3, 5, 8. And then IC is equal to FILTIC. This is an inbuilt function. For that, the inputs are B, A, those are the coefficients, yi, comma 0. So here we will solve it like this. We'll find natural response, we'll find forced response, and then we'll find total response. If you want to find out natural response, then we'll consider let input be 0. Okay, here if you observe, for FILTIC, the inputs are B coefficients, A coefficients, Y and X. Since I'm interested to find out natural response, xn represents natural response. For natural response, I won't give any external input. That's what is the meaning of natural response. What system is giving on its own is known as natural response. No external input has to be provided for it. So as a result, xi will become 0. This I'll use here. There is one more inbuilt function, filter. For that, inputs are B coefficients, A coefficient, zeros of 1 comma n, and then IC. As a result, I'll get natural response. Then n is equal to 0 till n minus 1. X is equal to 2 cap n, 2 power n. So it depends on what is there at RHS. And then this will vary. And IC is equal to, again, I'm going to find out forced response. For forced response, I'll consider external input, but I won't consider yi. So if you observe this line, FILTIC, B coefficient, A coefficient, yi part I made 0, and then I consider xi. So xf represents forced response. For that, B coefficients, A coefficients, I'll consider x as well as IC. Whereas if you observe here, I won't consider input. Input I made 0, total 0. Because no external input has to be applied in order to find out natural response. Whereas I should apply some external input for forced response. how system will behave for the external input. And then total response. In total response, I should consider both x as well as y. That is input xi as well as output y. So I found out natural response, forced response. Now I'm going to find out total response, which is given by IC is equal to FILT IC, B quotient, A quotient, YI XI. Total response is the one which is a combination or some or total of natural plus forced. As a result, I need to consider both output as well as input. So XT, filter of B quotient, A quotient, X IC. This will remain same because anyway we have considered input as well. And then I'm going to plot all of them, that is natural, forced as well as total response. Subplot of 3, 1, 1, because I need to plot natural, forced as well as total. So I need to split the graph into three parts. So that's why it is 3 rows, 1 column in that first part. In the first part, I'm going to plot natural response. It's a discrete, so stem of n, xn, title, natural response, x level n, y level amplitude. In the second part, I'm going to plot forced response. So 3, 1, 2, stem of n, xf. xf, it's a place where it's a variable where I stored forced response output. So title forced response, x level n, y level amplitude. Whereas in the third part of the same graph, I'm going to plot total response. So subplot of 3, 1, 3, stem of n, xt, title. So xt is a place where I stored total response output. So I'm going to use the same to plot it, to observe how it will look. So it is a place where you'll get the actual output or the final output. Title, total response, x level n, y level amplitude. Now I'm going to run this. Okay, it is asking A coefficient. Now we'll check this particular difference equation. If you observe this particular difference equation, A coefficients are the one which are associated with variable y or output y. So we need to transfer this to LHS. So what is the coefficient associated with y of n? It's 1. If I take this to LHS, the coefficient is -1. Similarly, if you take this to LHS, again the coefficient is -1. So what are the A coefficients? 1, -1 and -1. Similarly, what are B coefficients? B coefficients are the coefficients which are associated with variable x. Do we have any variable now with x? No, right? So we don't have any B coefficients. And then now it will ask for initial conditions. What are the initial conditions? There are two initial conditions, right? One is for y of 1 -1 and other one is y of -2. What it is? It is 1 and 0. Do you have any initial conditions for x? No. As a result, it is 0. So we will find out for first 5 values. Okay, so we'll consider n, capital N as 5. So remember this, I'm going to enter the same now. A coefficients are 1, -1 and -1 as per the equation for a Fibonacci series. So and it will vary depending upon the type of difference equation that has been asked. It's not the same. Only for Fibonacci series, these coefficients are true. Now if it is some other series, if I give some other coefficients, then make sure that go through that particular difference equation and enter the values corresponding to A, B, etc. So in the given equation, we don't have any coefficients associated with B, so I'll enter 0 for it. And there are some initial conditions here. They are 1 and 0. That is at y of -1 it is 0 and y of -2 it is 1. And do we have any initial condition for x? No, we don't have. So it is 0. And as I told, we'll calculate it for first 5 values. And we'll observe the output now. Now if you observe the output, so in natural response, it is 1, 2, 3, 4, 5. Forced response, it's completely 0. And total response is summation of natural plus forced. So that you will get total response. Okay. So even if some external forces applied to it, external input is applied, that won't affect this. It all depends on y only, right? No x term. So output will not affected by external input. That is what is the meaning. From the difference equation, do we have a term with x? In general, x represents input, y represents output, right? Do we have any term with variable x? No. What is the meaning of it? No external input. As a result, first you should get forced response as 0. So, and we are getting the same. But we have natural response. So within the system, it is depicting some output based on that particular difference equation. And total response is summation of natural plus forced. So it is the same as natural response. 1, 2, 3, 5, 8. See here, 1, 2, 3, 5, 8. We got the same. Similarly, you can enter any value of n and you can get the respective output. And I'll show you the plot. So as I told, we need to plot natural, forced as well as total. So we have only natural response. At n is equal to 0, it is 0. N is equal to 1, 1, 2, 2, 3, 3, 4. Oh, sorry. At 4, it is 8. At n is equal to 0, it is 1. At n is equal to 2, it is 2. At n is equal to 3, it is 3. At n is equal to 3, what it is? See here, output is 5 and then 8. We are getting the same. Here it is 5. If you observe, it is 5. And at n is equal to last value, okay, fifth value, it is 5. Since now in general in DSP it start from 0. So since n, the value of n is 5, it is n minus 1. So you will get at n is equal to 4, the last value. And we don't have any forced response because no external input is there, right, as per the equation. So it's all 0. And total response is summation of natural plus force. Since forced response is completely 0, total response is same as natural response. Hope you have understood this. Thank you.